This question might seem really confusing to start with, but there's some absolutely crucial information that we're given. And that is because P, Q, R, and S are all different positive integers, that means that 9 minus P, 9 minus Q, 9 minus R, and 9 minus S are all integers as well, because I'm just subtracting something. They could potentially be negative, actually, which is something worth thinking about. Because if we write down our factors of 9, well, it's actually just 9 as a product of its prime factors is 3 squared, and its factors are 1, 9, and 3. So remember, all of these have, well, P, Q, and R, and S all have to be different. So we've got to think about how we can multiply some things together, and that's where the negative comes in, actually. So we can't times by 9, actually. That one's out, because as soon as you start timesing, imagine this was 9, then all the rest of them would have to be 1, or you can have a 1 and 2 minus 1s, but then they wouldn't be different. So 9's out, and minus 9's going to be out for the same reason. But what will work are if we go with 3 and minus 3. So that will give us minus 9, and then 1 and minus 1. And it might take a bit. I'm not saying you're going to think of that straight away, but that's what we've got to realize to do in this question. It's kind of like we're using the factors of 9, but we can include negatives, and we've got to eliminate using 9 or minus 9. So once you figured that out, actually we're well on our way. 9 minus p is equal to 3. But by the way, I've just chosen to set them this order. It's actually, p could be any one of the 4, but it's just because we're only interested in the sum overall. So p is going to be 6. Q, what do I have to? I mean, I can just like look at it and think, how do I get minus 3? Q is going to have to be minus not minus 12, 12. They're all positive, aren't they? So 9 minus 12 is minus 3. And then R is going to be 8. And S is going to be 10. So if I add these all up, this gives 20, 16, 20 plus 16 is 36. And that is our answer.